Hi everyone, welcome to Scientific Measuring with Miss K. The purpose of this video, as it sounds, is to review the steps that you take when you take scientific measuring. So here's the first thing we want to talk about. There's kind of a measuring rule that we have, and what we think is whatever the measuring tool that you're using is, whether it's a thermometer or a graduated cylinder or a ruler or whatever, you read to the smallest marking on that measuring tool, and then you add one more digit after it. That last digit is kind of a guess to show you that you can be more specific than just the lines that you can actually read. Here's another way to kind of think of it. So think of it that for every metric measurement, there is 1 through 9 imaginary lines between the actual line you can read. So for example, let's say that this was the ruler that we had. So it was 1.1, 1.2, 1.3, 1.4. There are imaginary lines in between there that represent the rest of that metric measurement. So if you have an object that looks like this, you could read to 1.3, it's for sure past that, and then we're going to pretend these were imaginary lines. So then you would say it's 1.3, I don't know, it's somewhere more than half. So then I might say that it's like 1.36 or something like that. So again, these were pretend like imaginary lines that would not be on your actual tool, but you can imagine it. That's how you kind of make your guess for that last number. So let me show you what I mean by that. So if it was right on that line that we had kind of shown, you would put a 0. If it was a little past, you'd write 1 or 2 or 3 or 4. If it was half past the 2 lines, you would write 5. If it was a lot past that line, you'd write a 6 through 9. So here's what I mean. So let's get that imaginary ruler back in there. So here we go. If it had been right on this line, we would have put 1.30. If it was a little bit past, like if it only had been right here, we would have put 1.32 or 1.33. If it was half past, we would have put 1.35. If it was a lot past, we would put 1.36 or 7 or 8 or 9, that kind of idea. So that's what we mean by how you decide that last number. So right on the line that you can read would be 0. Half past would have been 1 through 4, or a little bit past is 1 through 4. Half past would be 5. A lot past would be a higher number. So again, that's imagining that these were imaginary lines that you are kind of putting in between the numbers you can actually read on your ruler or graduated cylinder or whatever it is. All right. So let's practice this a little bit. So if you had a balance, these just keep kind of adding on to each other. So you've got 0 plus 30 plus 4 plus 0.2. So 34.2 is for sure pass. And then we can count 0.2, 1, 2, 3, 4, 5, 6, 7. So we'd say 34.27. And then we need one more number to say, well, it looks like it's a little bit past that 0.27. So I might say 0.271 or 0.272, right? That's that idea that you say, how far is it past the line you can read? So 34.27, we could read all of that. So that's the 34.27. And then one more number to say it's a little bit past that 0.27 line. That's how we take our metric measurements. All right, for this next one, I want to see if you can try it. So go ahead and pause the video and try this measurement on your own. Okay, welcome back. Let's see if I agree. So these numbers keep adding on. 151.812, so 0.82, and then it looks like it's a little bit past, so I might put another 2. So 151.82 was what we could read, and then we need one more number to say it's a little bit past that 0.82 line. All right, how are you doing? Any questions? If there's questions, go ahead and pause the video and ask your teacher. Let's try some other types of measurements. How about a graduated cylinder? So in this graduated cylinder, this is a 60 and this is a 70. So that means it's going up by the ones place. 61, 62, 63, 64, 65, 66, 67. So the first thing we would write down is 67. There's no guessing yet because we can read to that 67. But it's not right on the 67 and it's not all the way to the 68. So we need a number in between there. So maybe 67.5. It looks like it's kind of right between the 67 and the 68. You might have said 67.6, that's okay, or 67.4, but the point is that we can make an estimate between the two lines that we can read. So 67 is what we write down, and then one more number to show that it's between 67 and 68. All right, here's another graduated cylinder. You go ahead and try this one. Pause the video before you hear the answer. This is measured in milliliters. Go ahead and try it. Okay, welcome back. Let's see if we agree with you. Here's 2.0 and here's 3.0. So that means that this is going up by 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And it looks like it's maybe right on the 2.8 or maybe a little bit past. So I said 2.81. If you said 2.80, that's okay. Remember, we go to the bottom of that curved meniscus. So it's not, that's why it's not way up here. So 2.81 would be our answer because it shows us that it's between the 2.8 and the 2.9, but just a little bit past the 2.8. So 2.81 would be the correct scientific measurement. All right, how about some thermometers? Let's take a look at this one. So this is 80 and this is 90. So once again, it looks like it's going up by ones. 81, 82, 83, 84, 85, 86. But it's past the 86. So we don't just put 86 because that's not a guess yet. That's just what we could read. So we need a number after the 86 to say 86 point what? So if it was right on the line, we'd say 86.0. If it was all the way up here, we'd say 87.0, but it's kind of in between. So maybe we say 86.6 or 86.5 to show that it's somewhere between 86 and 87. All right? Okay, here's another thermometer. Go ahead and pause the video. And now you try this one. All right, welcome back. Let's see if I agree with you. So still going up by one. So 0, 1, 2, 3, 4, 5, 6, 7, 8. That we're able to count, but it looks like it's a little bit past that 8. So we might say 8.1. All right, how are you doing? Any questions? If you have questions, go ahead and pause the video and ask your teacher. Let's try some others. How about a ruler? Now this ruler is measured in millimeters, and this is 3 and this is 4. So again, it must be going up by 0.1s. 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8. But then again, that edge looks like it's a little bit past. So maybe we say 3.81 or 3.82. So again, the rules always says, write down what you can count, 3.8. And then another number to say, how far is it past that 3.8? Just a little bit, we put a small number. If it was half past, we put 3.85. If it was a lot past, we would have put 3.88 or something like that. All right, one more practice. So ruler, you try this one. Pause the video. All right, welcome back. Let's see how you did. Now, this one is not very specific. So we can count that it's past the 7, but we can't count any other numbers. So that means that we just have one more number to say, well, it's quite a bit past the 7, but not quite all the way to the 8. So maybe 7.9, and that's it. You can't be more specific than whatever your measuring tool is that you're given. And since there was no lines written there, we had to guess or kind of make an estimate that, well, it's not 7.0, it's not 8.0, it's a little bit before, so 7.9. If it had been halfway through, we would have said 7.5. So remember, that's the idea that those imaginary lines between the lines you can actually count. All right, so that is some reviewing about scientific measuring. What if you are in Ms. Killinen's class specifically, now what I want you to do is I want you to work on the measuring practice assignment. I'd like you to show me or Ms. G before you submit it to Schoology, just so that you know you're doing it right instead of just turning it in. Remember the rule is read to the smallest marking on the measuring tool and then you add one more digit to show that it's maybe not right on that line or a little bit past or half past or that kind of thing. After you've practiced enough, if you're feeling ready, come on over and let me know that you're ready to test out of measuring. Thanks for listening. Bye.